So we only have 2 more sections. Then we have a review day, and the test will be next week. Okay. All right. So we have 2 more shapes today. We have a rhombus and we have a square. The plural of rhombus is rhombi. Okay. So let's start off with definition of a rhombus. Okay. This is a quadrilateral with all 4 sides congruent. Okay. So every side has to be the same. This side, this side. Okay. All 4 sides are congruent. So, is a rhombus also qualify as a parallelogram?
Yes.
Yeah.
Okay, so we know opposite sides are parallel.
So if it was always, sometimes never, rhombuses are always parallel.
Yes, rhombus is always a parallelogram.
Parallelograms are not always
Right,
parallel.
a parallelogram is a rhombus sometimes. Okay, now we have a couple theorems. We have 2 theorems. They're basically, and then we'll look at the converse. If you have a rhombus, this is special just for a rhombus. The diagonals are, what's the upside down T? Perpendicular. So if I draw the diagonals here, they make a right angle. Again, this is only true if it's a rhombus. It's not true for a regular parallelogram, and it's not true for a rectangle. The other one is that if you have a rhombus, the diagonals bisect opposite angles. So what does that mean? So we'll start off with one diagonal here. Bisect means to split in half. So these 2 are congruent. And these 2 are congruent. Not only that, but all 4 of those small angles. Right, because what do we know in a parallelogram? Opposite angles are congruent. So if they're bisected, so like if we know this is 20 degrees, this is 20 degrees, this is 20 degrees, this is 20 degrees. And then the other diagonal, the same thing will happen.
But they're not all like...
They're not all the same. So it's these 4 are all the same, and these 4 are all the same. Good. All right, let's see how that applies in our first example. So let's label. So first of all, it's a rhombus. So here, 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 and here are all congruent. AB is 2x plus 3. And BC equals 5x. And the measure of ABC, this whole thing, is 82 degrees.
341.
Okay, so what do we need to find? We need to find x, and then we're going to look for some other measurements. How do we solve for x?
2x plus 3 equals 5x.
Good, so we know they have to be equal. X equals 1. Good. All right. What's the measure of AD? 5. How do we get that? Because it's 5x. All of them are the same. Good. Measure of angle AEB.
90.
Oh, it's actually labeled, but even if it wasn't labeled, we would know it has to be 90. Okay, measure of angle ADB. Careful.
41.
41. So remember, if the whole angle here is 82, the whole angle here would be 82. But then these are congruent, so that would make it 41 degrees. Okay, how about BCD? Here's BCD.
Isn't it
like 180 minus?
Okay, so it's still a parallelogram. So if this is 82 degrees, we know these 2 angles here and here have to be supplementary. So what would 180 minus 82 be? 98. So this whole thing here is 98. So DAC,
Well, you put the 9.
this would, good. So this would also be 98. And then this would be half of it, which makes it 49 up here. Okay. Good. Questions? All right. So we are going to prove that theorem that diagonals bisect opposite angles. So we'll start off with,
Is there a way, like, you know how you do for you have to write out rhombus instead of like
yeah. So generally speaking, parallelogram is the only one that has the abbreviation. Okay. All right. So we have, all we know is that PQRS, this whole thing is a rhombus. And what am I trying to prove? I'm trying to get PQT congruent to RQT. Then,
So the triangle.
Yeah,
so if we can get this triangle congruent to this triangle here, we see that? So if we can get these two triangles to be congruent, then like CPCTC, right? We can get those two angles congruent.
Well, can't you two things? One, can't you say that all sides are like they're congruent because and then
So-
also the fact that since they're aren't they
Okay, we'll get to that. But let's start off with all sides are congruent. But if I'm just trying to get these two triangles, I can just say PQ congruent to QR. Now, if I wanted to write all four were congruent, that's fine. What is the reason? This is definition of a rhombus. Okay, so I have two sides congruent.
What can't you say it's 90 degrees?
You have to say
Angle that's like when it's towards
do we have
You don't have to say, if it's a rhombus, we automatically know that it's going to be a parallelogram. So all the theorems that go with a parallelogram are going to be true. So for example, what about these two segments? What do we know about PT and TR? Those are congruent.
That's because
Diagonals bisect each other. So I'm going to say PT congruent to TR. Now I'm going to use the parallelogram symbol here because, again, a rhombus is a special kind of parallelogram. So a rhombus implies a parallelogram. Parallelogram implies, diagonals bisect each other.
Then you could do
One more. So TQ. No, we have never proven theorems on a test or a quiz, but we've applied the theorems.
On the finals.
on the final what we did?
On the final.
Oh, because it was one we haven't done yet. I kind of spelled it out though. Yeah. Okay, so reflexive.
Side.
So we have three pairs of sides.
Wait, so rhombuses are parallel.
A rhombus is a special kind of parallelogram because if all the sides are congruent, then obviously opposite sides are congruent, which makes it a parallelogram. So I can say triangle. What do we want to name one triangle?
Oh yes,
PQT.
on the homework you gave the triangle.
Oh, I did? Oh.
Wow.
You'll have to point that out to me. Okay. PQT is congruent to triangle RQT. And we said that was good. And so we can now say these two angles up here, angle PQT congruent to RQT. Good.
Pretty straightforward.
Yeah.
Good other ones.
Yeah. Like I said, once we start doing a lot of and I wouldn't have, again, I'm not going to have you prove a theorem, but you might be able to apply it. Okay. What's that?
Theorem proofs are always really long.
Yeah, theorem proofs are definitely longer than when we apply them. Okay, definition of a square. So it's a quadrilateral that is both a rhombus and a rectangle. So if I took the definition of a rhombus, which says all sides congruent, right? All sides. And a rectangle, which means all the angles are congruent. Right? So I put those two.
All the angles of a triangle are congruent.
All the angles of a quadrilateral. If they're all.
I mean a rectangle, not a triangle.
Yeah. So if all the sides are congruent and all the angles are congruent, I have a square. Right? And a square, obviously, is a special kind of parallelogram. So there are no theorems specifically for squares, but anything that has rectangles and rhombi will apply. So for example, I know because it's a rectangle, the diagonals are congruent. I know because it's a rhombus, the diagonals are perpendicular. Okay?
Oh.
It's okay. These are just the converse of the previous. Yes. Yeah. Okay, let's just go to this part. We just want to check the box where it's true. Okay, so parallelogram, rectangle, rhombus, and square. Diagonals bisect each other. Is that true in a parallelogram?
That's true for.
Okay, so if it's true for a parallelogram, it's true for all of them. Because these are special types of parallelogram. Okay, which ones are the diagonals congruent?
No, rectangle. No.
Rectangle
Square.
and square only. Okay, because a parallelogram, think about it.
But didn't you say squares parallelogram like a minute ago?
A square is a rectangle and a rhombus combined.
Oh, rectangle.
Yeah. Okay. All right. Each diagonal bisects a pair of opposite angles. That's one we just did today. That's a rhombus
And square.
and square. And then diagonals are perpendicular, rhombus, and square. That's the other one we did today. Make sense? Okay. All right. Let's look at how can we show what shape we have. Okay. The easiest one is to see if we can show that it's a square. How would we show it's a square?
Distance formula.
So we could do distance formula.
So,
We could also do slope.
all sides are.
And right. So let's first just graph it. This is a super easy one here. So 0, 3, that's M. N is negative 3, 0. 0, negative 3 is P. And Q is 3, 0. Okay. What does it look like?
Looks like a square.
Looks like a square on its side.
A diamond.
Okay, so how would we show that it's a square? Okay, we could do diagonals.
Slope.
So the diagonals would
The
have.
angles.
Okay, so if it's a square, there's two things that have to be true. The diagonals would have to be perpendicular and congruent. Why?
Because then it would be a rhombus.
Okay, if the diagonals are perpendicular, that makes it a rhombus. And if the diagonals are congruent, that makes it a rectangle. So if both of those are true, then it has to be a square. So I purposely gave you some nice, easy points to consider. So let's look at NQ. Okay, so what is the slope of NQ? What happens when it's just a horizontal line? 0. And what is
Undefined.
what's the length? What's the distance of NQ? We can just count it, right? 1, 2, 3, 4, 5, 6. Okay. So the length of NQ is 6. And then let's look at MP. What happens when it's vertical?
Zero. It's
Undefined. If it's undefined and the other one is 0, we know they have to be perpendicular.
0 over 1.
Yeah. And what's the distance? What's the distance from M to P? We could just count because it's straight up and down. Probably 6. Well, let's see, right? 1, 2, 3, 4, 5, 6. Yes. So this is not just a square. We want to list all that apply.
Wait, I'm confused. So because it's undefined, it's 1 over 0.
Yeah, so this is a horizontal line.
So 0 and 0 over.
And this is a vertical line. So anytime you have a horizontal and vertical line, they have to be perpendicular. Okay, so this is a square. And what else? And a rhombus. And a parallelogram. And a rectangle. It's a rectangle because the diagonals are equal to each other. And it's sloped.
Oh, right.
Okay. So because these two are equal, I know it's a rectangle. Because these two are perpendicular, I know it's a rhombus. And if these two are true, all of them are true. You could also just write all.
Oh,
All right, last one. Did you get that, Xander? Here, I'll just zoom out a little bit.
I wrote down
Oh, okay.
what it was.
Got it.
I
Okay.
can look back and
Okay. So -4 is 0. That's our M. -3 is N. 2 is P. And 1 -1 Q. Okay. What does this one look like? Sometimes it's helpful to graph. It kind of looks like a rectangle. Would we agree this side is bigger than this one?
Yeah.
So I probably wouldn't even really check to see. What would we want to know if it's a rectangle?
The angles, if every side is
Okay, so we could do two things. We could do the slopes are all perpendicular. For the sides. Or we can do the diagonals have to be congruent. So here's the thing. We either have to do slope 4 times or distance 2 times.
this is we can count.
You get to decide. It doesn't matter to me.
I like distance.
So I'm going to check, since we haven't done distance formula in a while, I guess I'll probably do that.
Why
So,
can't we just count?
okay, but I want to...
How big
Sometimes,
is it?
listen, dear, sometimes we don't have such easy numbers to work with. So it's helpful to rely on, or what if I didn't give you a graph? I know. So if you want to do slope, go for it. I'm just going to review. So I'm going to do MP. Let's see. So I have 2 minus -4. So 2 plus 4 squared. And 2 minus 0 squared. I guess because, you're going to have to use distance formula again throughout this semester, throughout next year. So it's good to just review it anyway. This will be 6 squared is 36 plus 4. So square root of 40.
2, 10.
Good. It's okay if you need to show a few steps. It's just all I need to see is the setup. And we want to check is NQ the same.
How do you know whether to
Yeah.
square above and then you wrote rectangle now?
Oh, so we first looked at it, just like looking at it. I can pretty much rule out a rhombus and a square for this. Would you agree this side is definitely longer than this one? Okay, so then I look to, okay, is it a rectangle?
If it's not.
And it's not a rectangle, we could still have just a regular parallelogram. But the thing is, this is kind of like a proof. There's no one right way to go about this. You could start with all the slopes if you wanted. But that would only tell you if it's a rectangle or a parallelogram. It's up to you. But you'd have to do it 4 times. Versus distance formula, I only have to do it 2 times. Because I'm just checking the diagonals. So NQ, how did we, let's see. 1 minus negative 3, so that'll be 1 plus 3 squared. And then negative 1 minus 3 squared. So let's see, that'll be 4 squared, 16.
16, 32, 4, 2.
Which is,
2 root 8.
well, 4 root 2. If it's square root of 32,
Oh, you can do 4 root 2. I forgot.
okay, they're not equal. What does that mean?
It's not a
It's not a rectangle. So the last thing we have to rule out, if it's not a rectangle, then it can't be a square. Okay? So let's check the slopes. We'll just count them. So now we will ultimately do the counting. So let's see. This has a 1, 2, 3 over 1. Okay, so I'll just kind of write them next to it here. So this has a slope of 3. This one has a slope of negative 1 over 1, 2, 3, 4, 5. So negative 1/5. Okay. This has a slope of 1, 2, 3 over 1. So it has the same slope. And then the question is, does this have a slope of negative 1/5?
Yes.
Down 1 to the right, 1, 2, 3, 4, 5. So this is only what?
parallelogram.
Yeah, so only a parallelogram.
Wait. I thought all of those are different parallels, but it's
They are special types of parallelograms. So it's a parallelogram, but just because it's a parallelogram, is that going to make it a rectangle? No. Is it going to make it a square? No. So if it's a square, so this is kind of like the opposite. If it's a square, then it's all of them. Okay.